Every smartphone, electric vehicle, wind turbine, advanced military system, and artificial intelligence data centers depends on a group of materials that most people rarely think about. Known as rare earth elements, these minerals became some of the most strategically important resources in global economy. As countries race to dominate the technologies of the future, control over these critical materials is becoming a new source of economic and geopolitical competition. Unlike oil or natural gas, rare earth elements are not household names. They include minerals such as neodymium, dysprosium, terbium, and praseodymium, which are essential for producing magnets, high-performance batteries, precious electronics, medical equipment, and renewable energy systems. Although relatively small in volume, these materials play an outsized role in modern industry. The rapid expansion of artificial intelligence has dramatically increased demand for rare earth minerals. ICERs require advanced semiconductors, cooling systems, networking equipment, and high-performance electronics that depend on critical minerals throughout their manufacturing process. As technology companies continue investing billions of dollars in AI infrastructure, demand for these resources continues climbing. Electric vehicle represents another major source of growth. Modern EV motors rely on powerful permanent magnets made using rare earth elements. As governments encourage consumers to transition away from gasoline-powered vehicles, manufacturers are competing for secure long-term supplies of these essential materials. Renewable energy is creating additional demand. Offshore wind turbines require large quantities of rare earth magnets to generate electricity efficiently. Solar energy systems, battery storage facilities, and modern electrical grids also depend on a wide range of critical minerals. The global transition towards clean energy is therefore increasing competition for mining resources. One of the biggest concerns for governments is supply concentration. A significant portion of world's rare earth mining and processing capacity is concentrated in only a few countries. This creates potentially vulnerabilities if trade disputes, geopolitical tension, or supply disruption occur. Processing rare minerals is often more challenging than mining them. Extracting usable material requires specialized facilities, advanced technology, and significant environmental management. As a result, many countries are investing not only in mining projects but also in domestic refining and manufacturing capabilities. The United States and European Union, Japan, Australia, Canada, and several other nations have announced initial initiatives designed to strengthen supply chains for critical minerals. Governments increasingly view these investments as essential for economic security and technological competition. Mining companies have responded with renewable exploration efforts. Projects that were previously considered uneconomical and receiving fresh attention as prices and long-term demand expectations improve. Investors are financing exploration across Africa, Australia, North America, South America, and parts of Europe in search of new deposits. The financial markets are closely following these developments. Companies involved in mining, mineral processing, recycling, and industrial manufacturing have experienced a growing investors' interest. Analytics believe critical minerals could become one of the defining commodity investment themes of the coming decade. Recycling is becoming another important part of the equation. Electronic waste contains vulnerable rare earth elements that can potentially be recovered and reused. Advances in recycling technology may reduce dependence on newly mined materials while supporting more sustainable supply chain. Technology companies are also adapting product designs to reduce reliance on certain scarce materials. Engineers are exploring alternative magnet technologies, new battery chemistries, and manufacturing processes that improve efficiency while lowering critical mineral requirements. Environmental concerns remain a major challenge. Mining operations can affect ecosystem, water resources, and local communities if not managed responsibly. Governments and investors increasingly accept companies to meet high environmental and social standards before approving major projects. Artificial intelligence may help solve some of these problems. A part geopolitical analysis is improving mineral exploration by identifying promising deposits more efficiently. Machine learning systems are also helping optimize mining operations, reduce waste, and improve resource recovery. The geopolitical implications extend far beyond economics. Rare earth elements are essential for advanced defenses technologies, satellites, fighter aircraft, missile guidance system, radar equipment, and secure communications. Ensuring reliable access has therefore become a national security priority for many governments. International cooperation is expanding as countries seek to diversify supply chains. Strategic partnership, long-term purchasing agreements, and joint investment projects are becoming increasingly common. These collaborations aim to reduce dependence on any single supplier while improving resilience. Energy economies rich in mineral resources are gaining greater strategic importance. Countries with significant deposits may attract billions of dollars in foreign investments as global companies seek a new source of supply. Infrastructure development, transportation networks, and processing facilities are often built alongside mining projects. Demand forecast exploration strong analysis expect consumption of critical minerals to increase substantially over the next decade as artificial intelligence, electric vehicles, renewable energy, robotics, and advanced manufacturing continue expanding worldwide. Price volatility is likely to remain a defining feature of the market. Supply distribution policy changes, environmental regulations, and technological breakthrough can all influence prices rapidly. Investors therefore view the sector as offering both significant opportunities and considerable risks. Governments are increasingly creating strategic reserves of critical materials. Much like traditional petroleum reserves, these stockpiles are intended to provide protection during supply distribution, while supporting national industries during periods of market instability. The semiconductor industries also depend heavily on secure minerals supplies. Advanced chips require highly specialized materials throughout manufacturing, making reliable access essential for the global technology sector. As semiconductor production expands, competition for resources is expected to intensify. Financial analysts increasingly compare today's rare earth market to the early oil industry of the 20th century, just as energy resources shaped economic development during the industrial age. Critical minerals may determine leadership during the digital age. Investment in research continues. Accelerating scientists are searching for substitute materials, improving extraction methods, and more efficiently manufacturing techniques. Breakthrough could reshape global supply chain while reducing cost and environmental impact. Consumers may not notice these materials directly, but they influence the price and availability of countless products, smartphones, laptops, electric cars, medical devices, renewable energy systems, and even household appliances rely on stable supplies of critical materials. Looking ahead, the competition for rare earth elements is expected to intensify rather than diminish. As technologies diving further economic growth or require reliable access to these resources, making supply security increasingly important for government and corporations alike. The rare Earth's race represents far more than a battle over mining. It is a competition for technological leadership, industrial capacity, energy security, and long-term economic influence. The countries and companies that successfully secure these resources may gain significant advantages in these industries that define the 21st century. As artificial intelligence, clean energy advances, manufacturing, and digital infrastructure continue expanding, rare earth elements are moving from the background of global commerce to the center of strategic planning. They may be invisible to most customers, but they are rapidly becoming some of the most valuable resources in modern economy.